Then we have step 3 is to select the proper packaging. So based on the proper shipping name, every proper shipping name has a specific packing instruction that is associated with it. And so you're going to read that packing instruction, and that's going to tell you how it has to be packaged. Step 4 is packing. So once you have the packing instruction, step 4 is simply following that packing instruction, making sure that as you prepare your package that it's done safely. Step 5 is to mark and label the package. Step 6 is to fill out the documentation. And then step 7 is to make arrangements, which means getting your import permits, your notification, addressing any security concerns, etc. And that is the basic 7 steps of shipping. So for the rest of the course, we're just going to go through one step at a time. So that leads us to the first component of biorisk management, which is assessment. So classification and identification are essentially the assessment portion. And so these first 2 steps is our assessment. The next steps, 3, 4, 5, and 6 are our mitigation steps. And then step 7, the making arrangements, that's our performance step. And so here we have our 7 steps. So before we get into classification, the first thing I want to do is just review, and this should be a review for many of you, as you have probably are already familiar with this concept of risk. So what is risk? So when we talk about risk, we're defining risk as the likelihood of an undesirable event that involves a specific hazard, threat, or has consequences. And so in this case, when we look at risk, it's not just the probability that something bad will happen, but it's also a calculation of how severe the consequences could be involving that particular event or that particular hazard. And so the first thing, the kind of key thing when we're talking about risk that we want to understand is that risk is the likelihood of an undesirable event, okay? So, for example, if I ask, what is the risk of crossing the road? I have to think about all of the undesirable events that could occur if I were to cross a road. So I could get hit by a car. I could trip on the sidewalk. I could get lost crossing the road. And so when I'm calculating the risk, I have to think about all the undesirable events that could occur because I'm crossing the road. So what I want to do is I want to spend just 5 minutes. I want you to work in your tables, and I want you to, whoops, let me clear my drawings. I want you to think of what all those undesirable events are that can involve shipping. So take 5 minutes and identify 3 to 5 risks associated with shipping infectious substances. Now, obviously, one risk is a lab worker, or perhaps let's not say a lab worker, let's say a carrier so somebody who's carrying the package could get infected or exposed to a pathogen from contamination from the package. So that's one risk, is a carrier could be exposed to a pathogen. There are other risks, both safety risks and security risks, that could happen. So I want you to take 5 minutes and think of as many bad events or risks associated with infectious substance transport. So write those down, and then I'm going to ask Abiodun and Easter if you could collect and summarize, give me the top 5 risks associated with shipping collected from those groups. All right.
Damage, village. This village is not part of it. This. I mean, it's the wrong package. Lots of So we're adding text again. The things that are unimplemented wasn't specify why somebody is still maybe for wickedness. No, not really. But that is this. That is in the country. That's what I said. If you want to do it, then it's wrong by the transport. We talk about contamination of the environment. One infection of the handler, exposure to contamination, damage, so spillage, the wrong package, transporter exposure, loss of shipment, bioterrorism, theft. Any other one? Any other one?
Okay, let's collect the answers now. And if you wouldn't mind typing the answers into the chat box for me as they're read off. So let's see if we can come up with 5 or 6 really good ones. And please put those in the chat box.
You see?
Okay. Can you write your answer so that I can type it for you in the chat box?
Okay. Oh, we have this one that is okay, theft. Theft.
Hello? Can you just tell me the answer? Table by table or something like that? This time the president was journal. They are not taking their I'll break them.
Still get
Okay.
did he get so we got it.
Yeah, so I heard a few I heard somebody, we talked about the carrier being exposed to pathogen contamination. I heard, spillage, so contaminating the environment. I heard theft. What else? What are some other ones?
Loss of shipment.
Oh, yep, loss of shipment. So it might maybe not be stolen, but somebody just lost it. Good.
Transporter, exposure.
So
Exposure.
Transporter exposure.
yep, we got transporter exposure. That's number one. But maybe receiver exposure. Receiver exposure. But also the shipper. So the shipper or preparer exposed. Good. All right. What else? Any others?
Like terrorism.
Yeah, terrorism. All right. What? Any others?
Any others?
Yes, people say it.
I'll tell you one that a lot of people don't think about. But it happens is cross-contamination. So for example, if you have two primary containers and one contaminates the other primary container, let's say one was positive for COVID, the other was negative for COVID, but because of the cross-contamination, when they did the test results, they both turned out positive. And so you could get cross-contamination between containers. Primary containers. So that's another issue. All right, so I've got 8 risks: carrier exposure, spillage, contaminating the environment, theft, loss of the shipment, the receiver exposure. So the person opening the package gets exposed, the shipper or person preparing the package contaminates themselves or gets an exposure during the preparation process. Terrorism, and then actually, funny story about terrorism. In the US, we had a mail carrier who had taken a sample of HIV, so it was marked on the package. It was marked for HIV diagnosis. So the mail carrier was upset with some of his coworkers, and so he took a needle, filled it with the HIV, and he started like poking his coworkers and infecting them with HIV. That I guess that's a type of terrorism. All right, good. Anything else we're missing?
Not quite.
Okay, good. Let's look at the next slide. We're not going to do this exercise in the interest of time. I need to keep us moving. But I want you to think about this question. So what are the factors? So think about what factors contribute to the likelihood. Let's say, for example, getting contamination, the carrier, the spill, let's say the package spills, the carrier gets exposed. So what factors contribute to the likelihood of that happening? For example, whether a package spills or not, to a large degree, the likelihood of that happening depends on how well the material is packaged. So for example, a triple package reduces the likelihood of a spill. And then what factors determine the degree of consequences? So for example, if the carrier is exposed to the material, what would the consequences of that be? So let's do this next exercise. We're not going to do this one, but let's do this exercise. So think about those 2 questions. So in your group at your table, let's think about let's say So let's think about you are transporting 2 different biological materials. One is a milliliter of plasma collected from a patient suspected of HIV. So one package is 1 milliliter of plasma from an HIV patient. The other is 100 milliliters of a broth culture of Mycobacterium tuberculosis. So would the two samples have the same risk for transport? What do you guys think? Do those both have the same risk, or is the risk different? Yeah, that's right. So the risk is very different. Uh, you know, so if you were to break one of those, which one would you least want to break? Which is the one that has the most risk? Which of those two shipments has the greatest risk, do you think? The TB, right? That's going to have the greatest risk. So think about a shipment like that. And what are the factors that would determine the risk for biological material during transport? So what are the 2 or 3 key differences between shipments, let's say between an agent? So not in how it's packaged. Let's say both shipments have the same packaging. So let's not look at the packaging, but what factors would determine how dangerous a shipment is? So I want you to list, like, what are 2 or 3 key factors that determine how dangerous a shipment is. So I'm going to give you a minute to think of those. And then I want you to list all of the factors that determine the risk for shipment, and then kind of identify the 2 or 3 most important factors, and write those factors on sticky notes, and then organize them by your most important factor to, let's say, the second, third, and fourth factor that determines the risk of a shipment. So I'm going to have Abiodun and Easter walk around and help you guys with this. And then when you're done, I'd like to see kind of an organized list of the key factors for transport and shipping. All right.
Okay. No.
So the first step is just to list the factors. What are the factors that determine how dangerous a shipment is? And then that's part 1. And then part 2, organize those factors that have the most impact. So list them by degree, which has the most impact. Hey, Abiodun, while they're working on that, can you let me know what time lunch break will be?
Sorry, lunch break.
Can you let me know what time lunch break is?
Oh, yes, the lunch break is going to be at 4 p.m.
Ah.
Yes. 4 p.m. because we don't have people. So we go at 4 p.m. And if you are done for the day, after the lunch, you can go from there.
Very good.
Will that be fine, Eric?
Sorry, yeah, so if if possible, because we started so late and I need all the time, I want to finish today at 5:30. So people need to have a break though, for food sometime between now and then. Unless you want to go until all the way till 4:30. That's kind of.
You can take it all the way to 4:30. And then, yeah, and then we'll go for lunch and close from there. Will that be okay for you?
All right, well, we can take like an afternoon tea break, obviously, like maybe a 30-minute tea break, but I don't want it to be a 1-hour tea break, 30 minutes max.
Okay, so we can have tea break at about 3 o'clock. That's 2 hours from now. Is that okay? So we can go for a washroom break. So that somebody will not come out. We can go for a washroom break by 3 o'clock, 3 p.m. for 20 minutes or 30. And then we converge, and then you take it up to 5:10. Are you okay with that, Eric?
All right, that'll work for me.
That's a deal. Thank you.
All right, just let me know when you're ready with the so Abiodun, let me know when you're ready to report back the key risk factors.
Yes. So key risk factor. So Eric, would you like representative in group to give you the risk factors from that group?
Yeah, go ahead, Abiodun, if you want to lead that discussion, and then have kind of each group report the key factors and then decide together as a large group, what do you think the most important factor is that determines the risk of an exposure?
Okay. Yeah.
They're ready. Okay. Yeah.
Okay. I'll rather take it from the video. Yes. Okay. We can speak. Oh, really? Okay.
Give her the microphone. Pass the microphone.
Okay, we started with virulence. That of TB is it's very high compared to that of HIV.
No, actually, what we're talking about is what are the risk factors? Hello? Yes.
So another way to think about it is so if we go back to that scenario here that we talked about at the beginning, why is we already kind of mentioned this, but why is this shipment 100 milliliters of a broth culture, why is that more dangerous than 1 milliliter of HIV? So, and of plasma. So what are the factors that make one shipment more dangerous than another? Now, it could be, let's say I have a auger scab of E. coli in one shipment, and I have, like, say, a full petri dish of Brucella abortus. So which is more dangerous, and why? So what are the factors that make something more dangerous than something else? So really what I want to get at is, how do you decide whether something is high risk or low risk? I'll give you an example. When I did a visit to a laboratory in Cambodia, this was a large laboratory that did a lot of diagnostic testing, and they had a waste room, and inside the waste room was just a very small autoclave, a really small autoclave. And I asked them, I said, do you autoclave or treat all of your infectious waste? And the answer was, no, we don't, because we generate so much waste, we can only autoclave a small portion of that. And so they made a decision that they would only autoclave the high risk waste, and the low risk waste would not be autoclaved, and then it would just be transported offsite for incineration. They did not have an incinerator at the hospital, but they had an incinerator that was that they had to transport maybe 10 miles away. And so before they transported it, though, they wanted to autoclave treat the high risk waste. So my question was, well, how do you decide what is high risk? What makes something high risk versus low risk? Same thing in shipping. What makes one shipment high risk and another shipment low risk? What factors determine whether something is high or low? And so that's what I want you guys to come up with, is a list of the factors that determine whether a shipment is high risk or low risk.
Okay. So.
Thank you very much. For us, we have two cases: the mode of transmission or infection and the pathogenicity of the agent concerned.
Exactly. So the route of transmission is going to have a significant impact on the risk, and also the virulence, the infectivity, the virulence, the pathogenicity. Very good. That's probably the top of my list.
Okay.
Another factor.
Another factor. Another factor.
Virulence.
Yep, virulence, good.
Another factor. Yeah. I think it's your job. Okay. Another factor.
The amount of the infection on the agents, that is the degree of infectivity.
Oh,
Animals.
All right.
Not the virulence.
So you say that the difference of virulence.
No.
Yes,
So that's not considered to virulence. Okay.
Speaking of class of the different categories. So you have category A, category B. In terms of effective.
Okay.
I didn't quite hear that, but if it could help if somebody while they give the answer, if somebody could type that, just a summary of what she said into the chat box, that would be helpful. Then I could see it and hear it too.
Okay.
All right, good. Infectivity, virulence.
The concentration of the
Route of infection, good. All right, are there other, so I've got 3 so far: infectivity, virulence, route of infection, concentration. Very good. Yeah, concentration is important. Very important. Like a culture is much higher risk than, say, a patient specimen. So for example, if I took a swab, like say an oral swab versus a pure culture, the pure culture is going to have higher concentration and higher risk. Good. Other factors. Viability. Yep. Good. All right. Are there others?
Yeah, there are others.
We said
Not the stability of the organism is environment. Yeah. Stability is different from viability.
different from environment.
It's different from viability. Stability.
All right, good. Stability of the organism, very good. Environmental, like how long does it survive outside of in the environment if it's released? Like HIV is not going to survive very long at all, but tuberculosis will survive a long time, potentially a long time outside. All right. Okay, I think that is a really good list. So I'm going to share on this next slide. We've kind of identified some of the key risk factors that determine the risk in shipping. Now, I had mentioned earlier to kind of ignore the packaging, but so we have, for example, the 3 critical ones that are actually used when we talk about the consequences of shipment. So, for example, the infectivity of the material, the pathogenicity, that determines the consequences of an exposure. The amount of material being shipped. So if you're shipping a small amount, like a small volume, is less risk than a large volume. And then the concentration we talked about. So these 3 critical factors that are highlighted in red are what determines whether something is category A or category B. The other key risk drivers to determine how dangerous a shipment is obviously the type of packaging, the training and care of the personnel involved in the transport, in the preparation, the packing, the transport, the delivery, the opening, and then the marking, labeling, and communication of risk. So we could kind of divide up our factors. So here's a list of all the factors that kind of impact the risk of a shipment. So the ones on the left are factors that determine how likely, so what we see, how likely a package is to leak or spill. And then the ones on the right determine, to a large part, the degree, the consequences if a package did spill. And so I've highlighted in red those factors that determine so the virulence of the agent, the concentration of the agent, and to some degree the amount of the agent. But it's really these two factors, the concentration of the agent and the virulence of the agent, that to a large degree determine whether it's category A or category B. All right. So let's step into the first step, which is called classification. So that is determining whether something is high risk or low risk. How do you make that decision? Whether it's high risk, which is category A, or moderate to low risk, which is category B. Well, what I want you to do is open up your books. So let me stop sharing, and I'm going to have you open up your WHO guidance document. So let me pull that up. So we're going to open it up right to page. It's going to be in section 4. So this is it's going to start on page 9. So here's where the guidance document talks about the definitions and how we define a material for transport. So I'm going to have you turn to page 9 and kind of follow along. So let me go back to my slides. I will stop sharing this. All right. So this is the definition out of IATA for an infectious substance. So infectious substances are those substances that are known or reasonably expected to contain human pathogens. So a couple keywords here, human or animal pathogens. So the first keywords are known or reasonably expected. So notice it doesn't say may contain, potentially contains, possibly contains. It says known or expected. So these are infectious substances that are very likely to contain pathogens. The next thing that I want to highlight is infectious substances are those that contain human or animal pathogens. So you'll notice that plant pathogens are not considered infectious substances for transport purposes. And so we are only talking about human and animal pathogens. And for the most part, when we talk about animal pathogens, we are really just talking about those pathogens that affect species of agriculture, so agricultural concern. So if you have a pathogen that affects insects, for example, you know, insects aren't really animals per se, according to kind of this. So really they're looking at animal pathogens, meaning those pathogens that can affect agriculture. So chickens, sheep, dogs, cats, not just agriculture, but animals that are important to humans. So, all right, moving on. So they define, so now we have a definition of culture. So they have cultures and they have patient specimens. These are mutually exclusive terms. So a culture are the result of a process by which pathogens are intentionally propagated, intentionally grown. And so the opposite of a culture, so the cultures are considered high concentration, whereas patient specimens are considered low concentration. So patient specimens are those collected directly from humans or animals and includes things like blood, sputum, urine, tissue biopsy, swabs, and body parts. So in order to meet the definition of a patient specimen, the key word is they have to be collected directly. And that means if you process them, like for example, if you take a blood sample and you put that in a culture bottle, like a Bacti culture bottle, then that wouldn't be considered collected directly from. So if you put it in any type of growth media, then it is that is no longer a patient specimen. However, if you, like for example, take a swab and many of these swabs are placed inside a liquid that is not a culture media, but a preservative, like a PBS, a phosphate buffered saline, or something to kind of protect or in most cases not allow it to grow, but keep it stable until you can get it into a laboratory for later culture or other diagnosis. And so that is still, so a swab like this inside a transport media would still be considered a patient specimen, but a swab inside a culture media would be considered a culture. So anytime you've intentionally, so the key word on culture is where you have intentionally grown it, or someone has intentionally grown it. A few other definitions to be aware of: medical waste. So medical or clinical waste are those derived from medical treatment of animals or humans from bioresearch. So an important note that if the waste contains biological agents or potentially contains biological agents capable of causing disease in humans or animals, then it's considered an infectious substance. So and wastes, so we're going to talk about category A and category B. But a category A waste is considered category A, whereas a category B waste is considered a separate definition, which is regulated medical waste. But I'm going to get into that in just a minute. So let's look at the definition for category A. So I hope you're still following along on page 9 and 10 of the WHO manual, and you're highlighting and maybe writing notes on this as we go. So a category A infectious substance is a substance which is transported in a form that when exposure to it occurs is capable of causing permanent disability, life-threatening, or fatal disease. So the key here is fatal disease. So a category A is a pathogen that is capable of killing otherwise healthy humans or animals. So for example, SARS, we have SARS-CoV-2. We had the COVID outbreak. So SARS-CoV-2, so COVID has killed millions of people around the world. But SARS-CoV-2 is actually not considered a category A, and that is because in general, SARS-CoV-2 does not kill otherwise healthy humans or animals. It only kills those people who are immunocompromised, elderly, overweight, diabetic, and are not otherwise healthy. So typically category A are limited to the really deadly pathogens that kill most people, even healthy people. So category B are infectious substances which are still pathogenic, still capable of causing disease, but do not cause that high-risk deadly diseases. So there's actually a list of examples. So this is called the indicative list, and I'm going to have you turn back to the WHO guidance document. Let me pull that up. So this is the WHO guidance document. And I'm going to scroll down to the appendix. So sorry, it's all the way towards the back. It's going to be page number, here it is. It starts on page number 41. So this is the indicative list. This is the indicative list for biological agents. And as you can see from this list, it has a number of, it has, if you look here, UN 2814 infectious substance affecting humans, and there's a list of about 40 pathogens that they consider category A. And there's and these are pathogens that are considered UN 2814 infectious substance affecting humans. And so there are two types of entries here. We have the type of entry. So for example, the very first pathogen here is Bacillus anthracis. And you'll notice Bacillus anthracis, it has this term after it in parentheses, which says cultures only. And if we scroll down, most of these, this is cultures only, cultures only, cultures only, cultures only. These are all cultures only. But as we look down, there's one here, Crimean Congo hemorrhagic fever virus. You'll notice there's no cultures only after this. So what that means is Crimean Congo hemorrhagic fever virus is one of those things that is so dangerous that even in low concentrations, even in patient specimens, even in cases where you suspect it may contain Crimean Congo hemorrhagic fever virus, it is category A no matter what. Whereas Bacillus anthracis that we see at the top of the list, this is only category A when it is in culture form. If it's not in a culture form, then it is considered category B. So you could have for example, you might go find an animal that is suffering from lesions, and you suspect these lesions are caused by Bacillus anthracis. So let's say you collected some pus from the pustule, or a swab from the lesion, and you're taking that swab back to the laboratory for analysis. That swab would be considered a patient specimen, and therefore would be category B. But if I grew that bacteria on an agar plate, or if I put that swab inside a culture media, then I would have to consider that a category A, because it's high risk Bacillus anthracis. All right. So go ahead and take a look at that list. You'll see things on this list. For example, we have here, we have hepatitis B virus. That's kind of common. That is cultures only. So only high concentrations of the hepatitis B virus. We have, for example, here, human immunodeficiency virus. So HIV. But again, HIV is only listed as a culture. So if you have a culture of HIV, it's considered category A, whereas patient specimen with the HIV would be considered category B. Let me go back to my presentation again. So some things to remember with this particular list is this list is the table are just examples. It's not exhaustive. Now, this table was first created in, I think, around the year 2000. And since that time, the table has not changed. They've not added anything new to it. And so you'll notice there is no SARS, not even SARS-1. So SARS-CoV-1 or MERS or SARS-CoV-2 are not on this list. In fact, any emerging pathogens that have come out since the year 2000 are not even listed here. That doesn't mean that they shouldn't be category A or category B. Remember, these are just examples. So new or emerging pathogens meeting the same criteria should be classified as category A. Cultures may be category A or B depending on the microorganism. So for example, if I had a culture of salmonella, salmonella is a pathogen, makes people sick, but it's not one of these deadly pathogens. And so even cultures of salmonella could be shipped out as category B. Salmonella is not on the list. All right, so let's do a quick scenario. And what I want you to do is, like you have your sticky notes, right? So on your sticky note, you can hold up A or you can hold up B. So if you think it's a category A, hold up the category A. If you think it's a category B, hold up the category B sign. So here is the scenario. We have children at a local elementary school are developing a rash, and we don't know what is causing that rash. Based on how it is occurring and the distribution of the spread, we strongly suspect an infectious agent to be the cause. So it could be something like chicken pox or measles or some other infectious agent, some virus maybe we haven't detected before. No one to date. So currently no children have suffered any life-threatening or fatal complications. So you've been asked to collect samples to test for a variety of possible infectious agents. You're going to see, is this measles? Is it rubella? Is it chicken pox? Is it maybe some other herpes virus or something like that? So the question is how are you going to transport these samples? Are you going to ship them as category A or category B? So go ahead and hold up your signs, whether you think it's A or whether you think it's B. So good. Someone says a B. Can't see that one. What is that? Write it dark. It's hard for me. So write it dark on the. Oh, B. Good. I see the B. Good. So we have two B's. B. Good. B. Good. All right. So everyone's classifying this as B. So I think that category B is a proper way to classify this. All right, good. So I just wanted to make sure most people were getting B's. B would be the correct answer. And the reason why it's B is because it's not causing any life-threatening or fatal complications. So in that case, we are going to initially treat this as category B.
So Atama for everybody. Atama. Don't go to that.
All right. Okay, thank you, Dinloye. All right, so so the question that often comes up is what if you know or expect a pathogen to be present in the sample, but you don't know which pathogen? Well, in that case, it's shipped as category B. If it's not causing life-threatening or fatal disease. But if it's an unknown agent and animals are dying, so let's say you're investigating an outbreak at a chicken farm and 90% of the chickens have died, in that case, it's probably a category A. All right. So there's a third category. So we talked about category A, we talked about category B. There's a third category, which are the exceptions. So these are the ones that are not regulated at all. And so there's a list. If we let me go back to the WHO guidance document. Where is my WHO? Oh, I didn't close it, did I? Ah, there it is. Good. Okay, so let's go back to the WHO. We're going to go back up to the classification one. So this is back on page, I think it's on page, so we have category A. So you can read through that. That talks about what category A is. And we have category B, and then we have medical waste that is defined. And then we have category B, 522 is category B. And then we have, oh, wait, they didn't have it in here. They should have listed it. So, so interestingly enough, in this version, in the newest version, they don't specifically call out the exceptions. So it says, with the exception of substances versus, let's see, it's right. So they have this thing called, so these kind of 7 exceptions. So you'll notice these exceptions are listed here. But let me go through those exceptions. So these are the exceptions that are found in the IATA regulations. And there are 7 exceptions. Now, what they mean by an exception is they're not regulated. So there's no packaging, there's no marking, there's no labeling, there's no documentation. These are not regulated or not considered dangerous goods. And so these 7 things are listed here. So one is biological materials that do not contain infectious substances. So, for example, human cell lines, animal cell lines, or cell cultures that are grown that are known or reasonably expected, I could say, to be pathogen free. And then number 2 is non-pathogenic microorganisms. So things like Bacillus subtilis, non-pathogenic E. coli, those biosafety level 1, risk group 1 cultures are not considered dangerous goods. And then pathogens that have been neutralized. So for example, if you've autoclaved it, or you've heat fixed TB slide, or you have stained pathology tissues, formalin fixed tissues, ticks collected in alcohol, those types of things. So if you've neutralized the pathogens, inactivated them in some way, they're not considered infectious substances, not regulated. Environmental samples, food and water samples, mosquitoes caught in a trap for malaria screening is an example of this. So food samples that you collect to test for, say, foodborne illnesses, or water samples that you're collecting to test for coliforms, things like that. Food, water, environmental samples are not considered, they're specifically accepted. Dried blood spots, so DBSs, are not regulated. Fecal occult blood screening samples, and then any blood or tissue collected for or related to transfusion or transplantation, these are not regulated. All right, so those are the 7 exceptions according to IATA. And then there's an 8th, and the 8th is called an exemption. So these are called exceptions. So let me kind of highlight that word for you. So we have the word exception, and then we have the word exemption. So an exempt patient specimen. So these are a little bit different than exceptions. These are called exemptions. So exempt patient specimen, these are patient specimens, so blood, body fluids, tissues, swabs, sputum samples, etc. So if you have a patient specimen for which there's minimal likelihood that pathogens are present, they're not subject to the regulations if the specimen is transported in triple packaging and they're marked on the outside with the word exempt human specimen. So before you can call it an exempt human specimen or exempt animal specimen, you have to use a professional determination, professional judgment. And that judgment must be based on, or should be based on, known medical history, symptoms, individual circumstances, and endemic local conditions. All right, so this is the one exemption. So what the exemption means, so if you think about the difference between an exception and an exemption is something that is not regulated at all, no packaging, marking, labeling, or anything. An exemption says if you package it, so if it's triple packaged and you mark exempt human specimen on the outside, then it's accepted from all the other regulations. So an exemption is like an exception, but requires just a little extra to get it to that level. All right, let's do, yep. Do we have a question? Do we have any questions? And so what I'm going to do is I'm going to have you type the questions in the chat box. So let them ask the question, but let's type the question in the chat box so I can see those.
Okay. Can we ask this now?
You can ask.
Yep.
So, different collected from the HIV positive patient. And what would it be considered as? That's exempt.
Sorry?
DBS card collected from HIV patients.
I heard that one. So a DBS card collected from HIV patients is accepted. It's not regulated. No packaging, no marking. It's not considered a dangerous good. All right, something else. All DBSs are considered not unregulated, not restricted.
Just those extra
clarification, exemption and exception. You said something about triple packaging for the exempt patient specimen. Could you clarify for the people who like to get you very well?
Yeah, so yes, I think I understood your question. So exempt patient specimens, so that could be a human sample or an animal sample, those that are collected directly from humans or animals. If you suspect that there is a pathogen present in those samples, they are considered category B or potentially category A if it's a really high risk shipment. But if there's minimal likelihood and no suspicion of an infectious substance present in the sample, then it's considered exempt only if it's been triple packaged. So what that means is all bloods, body fluids, tissues, all human samples must be triple packaged. Those that are very low risk are considered, you just mark exempt human specimen. Those that are moderate risk are marked category B. Those that are super high risk are marked category A. But all blood, body fluids, and tissues, all specimens should be triple packaged. I hope that answered your question. If not, let's type it in the chat box so I can get it a little more clearly. All right, next question. Any other questions?
Any more questions?
All right, let's go on then. Let's see how much you have how much you've learned. All right, so we have a letter. So let's do a scenario. We have a letter that's containing a terror threat, and that letter, so it's has some white powder. So when it's opened, some of the white powder spills out. And on the letter, it says that you've been infected with anthrax or something of that nature. And let's say the police have determined that this is a credible threat, that they believe this may be a real incident. So what you're going to do is you're going to, you've been asked by the ministry to go to the office building where this happened, collect nasopharyngeal swabs from potentially exposed office workers. So the swabs will be transported to a local clinical laboratory for analysis. So the first question I want to ask is, are these infectious substances? The swabs that you've collected, are they considered infectious? Yes or no? What do you guys think? Go ahead and say yes. Yes or no? Raise your hand if it's yes. Are these infectious? Yes. Raise your hand. All right. Good. Anyone say no, this is not infectious? Does anyone say these are not infectious? All right, good. So everyone agrees these are infectious substances. So how would you categorize these as A or B? How many people think B? I'm hearing B. Anything else? Anyone says A? A few people say A. Okay, so let's look at it. So these are infectious substances. So now we have to decide. So we believe that these are Bacillus anthracis. That's what it says. You know, this is anthrax bioterrorism scenario. So we believe that this is Bacillus anthracis. We believe that the people were exposed to Bacillus anthracis. And so when we've collected the swabs, so we would expect to find on some of these workers colonies or bacteria in their nasal passages. So we've collected that. So we expect to find, but the question is this a culture? Is this a culture of anthrax or is it a patient specimen? Yeah, this is a patient specimen. And so if we go back and we look at the list, so if we look at the list, let me share the list again. So if we look at the where is my list? Here it is. So if we go back and we look at that list of agents, that this is found on page 40. So if we turn to page 40, and we notice right at the top of the list, we have right up there Bacillus anthracis right there. But notice it has the word cultures only. So because this is a patient specimen, it is not a culture. So cultures only are category A. Patient specimens with Bacillus anthracis would be category B. And so the correct answer for this would be category B. All right. So somebody had a question. They're still not clear on the issue of the difference between exempt and exception with respect to triple packaging. So here's, let me see if I can answer that. Let me go back and share my screen. So before I go too far, let's make sure we understand. So if your material meets any of these 7 exceptions, so if it's any of these 7 exceptions, any of these, then there are no packaging requirements. So they don't have to be, if you triple package them, great. You can triple package them, but they don't need to be triple packaged. There's no triple packaging requirement for any of these 7 items. These are the exceptions. So here we have exceptions. So when we talk about exceptions, there are no packaging requirements. But when we talk about exemptions, so when we talk about the exempt patient specimen, these require triple packaging. So exempt patient specimens require triple packaging. Category B requires triple packaging. Category A requires triple packaging. So that is the difference. Hopefully that'll answer your question. All right. So let's go back. So we've decided that these nasopharyngeal swabs are category B, and I would agree. The correct answer here would be all right, there we go. So the correct answer here would be category B would be the correct answer for the swabs. And likely these swabs only contained a few pathogens. So we assume that what they have in their nose is a very small amount, very low concentration compared to maybe what is in the white powder itself. So the white powder would be a culture, would be a high concentration, would be category A, but the nasopharyngeal swabs, low concentration, lower risk, could be category B. All right, so now let's go to part 2. So now we've taken our swab, and let's say on the swab we've done some culturing, and we have determined, based on some gram stains and a few other things, let's say we've determined that the morphology of that colony and that colony there, those 2 colonies, appear to be gram-positive, spore-forming, rod-shaped bacillus. And based on the color, the shape, the size, the staining, we have determined that those 2 colonies happen to be, we think that they're Bacillus anthracis. So what I'm going to do is I'm going to subculture a little bit of that colony. I'm going to subculture a little bit of that colony, and then I'm going to send those 2 subcultures on auger stabs, and I'm going to send them to the central lab for verification. So how would you classify that? A or B? These are obviously infectious substances, but what would you call that? A or B? I'm hearing A's. Is that correct? A? All right. Yes, so in that case, the correct answer would be A. So category A, because now we have a culture of, or a suspected culture of Bacillus anthracis. All right, let's do another scenario. So we got blood that we're collecting from a patient with AIDS, and we're going to determine HIV viral load. So what do you guys think? Is this A or B?
Eric, can I ask a question?
So what do you guys think? You want to use your cards, hold up your card and say, put a B if you think it's category B, put an A if you think it's category A.
Eric, can I ask a question? Can you hear me? I don't think you can hear us.
So what, it's hard to hear the question. Can we type the question in the box?
Okay. Okay. Can you type this question? Okay.
Okay. Please.
What's the question?
Right.
Yeah. No, I really want to know.
Yes.
Look, I'm saying, yes. Okay, I want to know the danger of, from the scenario we painted, the danger of classifying the swab as category B, the anthrax swab as category B, only to discover from the culture that is now an anthrax virus, and we now say it's category A. What's the danger?
Right. And so I would say, initially, if you based on, so let's say I'm collecting a swab, let's say I have a patient that has a hemorrhagic fever, they're bleeding from their eyes, they're bleeding from their lips and mouth, and they have a high fever, and they were exposed to somebody with Ebola, for example, and I'm taking a sample. In that case, I don't know, it could be Ebola, it could be something else. But most likely based on the symptoms, I'm going to suspect that it is a hemorrhagic fever virus, and almost all hemorrhagic fever viruses are category A. As far as bacterial pathogens, even the most deadly bacteria pathogens such as Brucella abortus, Shigella dysenteria, maybe Bacillus anthracis, even the most deadly bacterial pathogens are all considered category B as patient specimens and only become A when they're cultured. The only thing that is category A as a patient specimen are hemorrhagic fever viruses and pox viruses. So things like smallpox or monkeypox, or, well, not even all strains of monkeypox. In fact, the latest outbreak of monkeypox, I know maybe you've heard about the Western clad. Those are considered category B, really, but it's only the Eastern clad that are considered category A. So the latest outbreak of monkeypox, even determined by CDC and WHO, they've determined is a category B as a patient specimen. So almost all patient specimens are going to be category B unless you suspect either a pox virus or a hemorrhagic fever virus. Does that make sense? Almost all patient specimens are going to be category B. Now, if there's an outbreak ongoing of, say, Ebola in your country, those then, Ebola samples that you suspect might have Ebola are going to be category A no matter what. I hope that answers the question.
Yeah.
All right, let's go back to the HIV scenario. So how are we going to classify this test tube of blood? What do you guys think? Is this A or B? Go ahead and put your answer on a sticky note and then hold that sticky note up, whether you think it's B, or if it's A, hold up a sticky note with A on it. Let's see what we got.
What's the question?
How would you Just answer this.
All right, what do we have? Okay, good. Yep. I see an A. B. Good. B. B. Good. B. All right. Most people are saying B. A. One A. Two A's. Yep. Three A's. A few A's. B. Okay. Good. B.
Yes.
All right. We have any more? We have B. Good. Yep. And the B. Yep. Category B. And is that I couldn't see that one. All right, but it looks like most people say B. So let's good, category B. All right, so let's look at this a little closer. So here we have one of the first things I want to ask is the substance infectious? Well, obviously, if the patient has AIDS and I'm determining HIV viral load, I would expect the pathogen to be present in this sample. So in this case, the answer is yes, it is an infectious substance. The next question is HIV on the list. So we look at that indicative list. That list is found on page 41 of the WHO guidance document. And the answer is yes, it is on the list, but it says on it cultures only. So only cultures of HIV are considered category A. In this case, is this a culture or a patient specimen? What we have here. This is a patient specimen. It is not a culture. And so it is a low concentration. And so in that case, because it's not a culture, then the correct answer would be category B. I would classify HIV for viral load testing as category B infectious substance. One thing to remember, category B are still dangerous goods. They still require packaging. They still require marking, labeling, even some documentation. So just because it's category B does not mean that it is necessarily safe. All right. So category B are still considered infectious substances. All right. Next, let's do one more. So here we have a urine sample, and the urine was collected from a patient that has symptoms of gonorrhea. So gonorrhea is, yeah, do we have a question here?
I have a question, the last item of the time. From the list, we have issues that make HIV be in category A rather than B. Only the last aspect, which is not cultural by the patient person, but all other three medical practice to be in category A. So I don't know why you're putting it in category B instead of A.
I didn't hear any of that. Can we type the question in the chat box? It sounds very muffled. I couldn't understand anything. Can we type it in the chat box?
There is echo in this form.
Okay, I think he's saying that all the other reasons support HIV being in category A, except the last one. So there are three previous reasons why it should be classified as category A, and only the last reason makes it to be in category B. So why, if there are three reasons for it to be in category A and only one reason for it to be in category B, why are you putting it in category B?
All right. I'm not sure. Please. It's hard for me to hear what you're saying. Just type it in the chat box. But I do want to. I think I'm going to try to answer this question. So one way to think of it is category A is reserved for the highest risk most dangerous shipments. A majority of, like, not a majority, but like 99% of all shipments that are infectious, probably maybe 99.999% of all shipments that are infectious are category B. Category A is reserved for those pathogens that if they were to leak or if somebody was to be exposed to them, this would be a national emergency. So if a package that is leaking category A spills or you're exposed to it, it means almost certain death. And so category A is really the really high risk shipments. The hemorrhagic fevers and the pox viruses, the really outbreak situation. So let me give you another example. When SARS-CoV-2 first emerged, lots of people were dying, and all samples of suspected SARS-CoV-2 patient specimens, all samples were considered category A. But after a few months, as the virus continued to spread, and as we understood the epidemiology of the COVID infection better, we started to see that many people were getting infected, but not dying from COVID. And so after, say, maybe 4 or 5 months of the pandemic, the shipment of patient specimens with SARS-CoV-2, the risk went from category A to category B. And even today, the CDC in the US has determined that even cultures, so even isolates, patient isolates, and cultures of SARS-CoV-2 can be shipped out as category B. But that's because today, most people now have either been exposed to SARS-CoV-2 and we've kind of achieved herd immunity in a sense. We also have vaccines. We did not have vaccines in the beginning. So before there were vaccines, before we had herd immunity, SARS-CoV-2 was much more dangerous. Now, if somebody gets infected with COVID, it's not a big deal anymore. It's not a national emergency. And in that case, category B is perfectly fine for those shipments. So good. So I see typed in the box, there are 3 reasons why it should be in category A and only 1 reason to be in category B. So why are you putting it in category B? So one way to think about it is, like, is it infectious? So when we look at this first question, I said, yes, it's infectious. So remember that 99.9999% of all infectious substances are category B. So just because it is infectious does not put it in category A. Next, is HIV on the list? Yes, it's on the list, but it's only on the list as a culture. So actually, it's not on the list because this is not a culture of HIV. It's only cultures of HIV that would be category A. And so while HIV is on the list, it's only there as cultures. This is a patient specimen, and therefore it is not on the list. So the true answer of this is no, it's not on the list, and therefore it should be on category B. So early on, maybe HIV was considered category A, but as we understand the epidemiology of HIV, it's not really spread. So if I have a package that's leaking HIV, the risk of exposure is fairly low. Also, we have vaccines and we have treatments for HIV. So if somebody gets HIV today, it's not really a death sentence anymore, like it was early on. And so HIV at least in the Western world, is no longer considered a high risk for shipping. Also, when you think about the endemicity, there are so many cases of HIV. It's prevalent, so people are not very unlikely to get HIV from a spilled package. All right. So let's go to this last scenario. I hope that answers your question. Remember, category A is really reserved for the highest risk shipments, the really national emergency if they spill or leak. Call out the hazmat teams, notify the fire department, the police, the emergency responders. It's a big deal when a category A package is damaged or leaks. All right, so let's go on. So now we have gonorrhea. So gonorrhea is caused by a bacteria called Neisseria gonorrhea. And we are collecting the urine from a patient who has symptoms. So obviously, this is an infectious substance because we got it from a sick patient. And we know that gonorrhea, if the patient has symptoms of gonorrhea, it is very likely that we're going to find lots of little gonorrhea spirochetes swimming around in the urine. So the next question is gonorrhea on the indicative list? So go ahead if you want and look on the indicative list. So let's pull up the list. That's going to be on page 41 of the WHO document. So here is the list. So we're going to look under the N. So we have Nipah virus, we have Mycobacterium, and then on the next page we have Omsk hemorrhagic fever. So notice there's no Neisseria gonorrhea. So the bacteria is not on the list. So just because it's not on the list does not necessarily mean that it is not a category A infectious substance. But let's talk about what we do know about Neisseria gonorrhea. So does gonorrhea cause life-threatening or fatal disease in otherwise healthy people? And the answer would be no, it doesn't. In fact, millions of people are infected with gonorrhea, or used to be infected with gonorrhea, maybe not so much anymore. Gonorrhea is easily treated by antibiotics. So it's not really a big national emergency if people are exposed. And so we could say, yes, it is an infectious substance. No, it's not on the list. So therefore, it would be category B would be the correct answer here. All right. Are there questions?
Yes, the question.
So go ahead and ask the question, and then if you wouldn't mind typing it in the chat box too, so I can see the question.
No, I'm just wondering, you said that not because it's not on the list does not mean it is not a category A substance. Isn't that a contradiction of what you just said?
Yeah, so I think what you're saying is the list itself. So the list is just examples. The list is not a complete list. They're just examples of pathogens. So I know that Neisseria gonorrhea is not on the list. So I know that this pathogen is not on the list. But just because it's not on the list, I have to ask the next question is, well, should it be on the list? And in my opinion, gonorrhea is not that serious, not that high risk. And so it shouldn't be on the list. It's not on the list and it shouldn't be on the list. So I am very confident that it is a low risk. This is a moderate to low risk shipment. And so I could ship it as a category B. Does that answer your question? I hope. If not, let's type her question into the chat box.
It does.
Okay, good. All right. Any other questions?
Any other question?
Yep.
No.
Okay. All right. So let's go on. So just a few changes that have happened recently. So in 2021, 2022, there weren't any changes, but there was a few changes in 2020. So if you've had shipping training before and you're coming back for refresher training, in 2020, they made a change to the definition of a culture. And they basically said that if you intentionally infect an animal with a pathogen, so let's say a research animal that you've intentionally infected, then you have to treat samples from that animal as if they were cultures. So depending on the material and the professional judgment, some intentionally infected animal tissues may be considered as cultures for classification purposes. So that's the only major change that have happened in the last few years. All right, so what I want to do is you should have in your book a list of I think 13 agents. And so what I'm going to do is I'm going to have what we're going to do is let's take a 20-minute break. And when we come back from the break, we are going to work on this table. So I'm going to have you step out and then come back. It is now it is 2:30?
Yes.
All right, so let's come back at 3 o'clock. I'll give you guys until 3 o'clock. Have a nice long break. And then when you come back at 3 o'clock, we'll start again and we'll do this exercise. Before you leave, though, I want to grab Abiodun and Easter. I want to explain the exercise. So you guys go ahead and go on break. And then Abiodun and Easter, can you guys come up to the computer and can I explain this?
Okay, Easter and President, come up to the computer.
Quickly, come to the computer.
The others can go on break.
Everybody move out.
He wants to talk. Where's President?
Okay, just a second. I'm pulling something up. So what I'm worried about is I don't think that we, where is it? Just a sec. Did you print out, was there a student guide? Did you guys print out the student guide from the matrix? Did you, Abiodun, did you print out a student guide?
Come again.
Did you print out the student guide for the course?
Yes, we have a student guide.
Okay, good. So let me show you in the student guide. I'm bringing it up. I'm bringing the student guide up. Just give me a sec. Where is it? Controls. Where's the shipping course? All right. Okay, good. All right, let me bring it up on the screen. Okay, so here is the GBRMC net, right? And we have it's the student guide right here. So here we have the student guide. Let me open that. All right, let me stop sharing and then I'm going to share the student guide. All right, so in their student guides, so when they come back from the break, it's coming up, just let it come up. All right, so in their student guides on So I don't have this slide. But right here, they have an exercise in the student guide. So here, you see this form that's here?
Yes.
This form. This form should be in their student guide. Oh, shoot. I got it. There it is. This form. Do you see that one? Is this form available in their student guide, in their printed student guide? Is it there?
No, it's not.
It should be slide number, so it's not the PowerPoint. It's not in the PowerPoint. It's in the student guide. It's page 45 of the student guide. So the student guide looks like this, where they have the slides and then they have the lines for notes.
But would that be a supplementary material? I think that is.
No, it's in the supplement. Well, yes, it's in the supplementary material, but under the student guide. So the student guide looks like this. So it's the student guide. This is the first page, and then it's got like slide and notes, slides and notes like this. So you just printed the PowerPoint, right? You didn't actually print the student guide. Is that correct?
No, well, this not, that's not the form of here.
If you did, it's okay. So let's do this. When people come back, I'm going to try to center this on my screen. So let's, if they don't have this, that's okay. They should have, okay, what they should have. Can you show me what it looks like in the student guide? Or what you have printed in their printed material? Can you hold it up so I can see it?
Sorry, it's not here.
Yeah, but show me what's there. I just want to see what's in the book, because it might have this slide here. It might have like, for example, if it has this slide, let me share my screen. Where is the PowerPoint? Here's the PowerPoint. So if it has, oh, dang it, all the answers are there. It's going to have that slide in it, isn't it? Is that slide there in the printed material?
Let me just check.
Show me the printed material. The book, the handbook around this exercise.
Oh, the handbook, okay. We have that. We have this.
Can you show it to me? Show it to me so I can see it. Hold it up in the camera so I can see it.
Hold it up in the camera. No.
Yeah, let me see. Okay, a little closer. Yeah, so it has all the answers, right?
How about this?
Oh, perfect. That'll work.
Can you check this?
Yeah, that'll work. That'll work. Perfect. So this is what I want to do when they come back. When they come back, don't let them look in their books, because the answer is right here. You see, the answer to those questions are printed in the slides. You see that?
Yeah.
So I don't want them looking at the answers, but I want you to hand out that sheet. So that sheet will look like this.
Okay.
Let me stop sharing my screen. So let me share again. Good. So when they come back, I want them to sit in their groups and work together to answer these questions. And I want them to mark it as A, B, exempt or not regulated.
Okay.
And just do, so when they do it, I only want them to do, wait, what am I sharing? Hold on. Yeah, I'm sharing the right one. Okay, what I want them to do is just, there we go. Just fill out this part right to here. So just these 4 columns. I don't want them to do this one. Don't do this one yet. We'll do this one a little bit later. We'll probably do this one and this one. We'll probably do that tomorrow. Maybe. We might have time to get it today. Hopefully we'll get it today. But what I want them to do when they get back from their break is don't let them look at their books. Just hand out this piece of paper, and they can work in tables if they want to help each other, or they can work individually. But I want them to put an X here like this, or an X if they think it's B, you know, whatever column they think it is, I want them to put a check mark in. Does that make sense?
Yes.
All right. So have them just fill in this part of it. Don't do this one yet. We'll do this column, the UN number and proper shipping name. We'll do that in the second part of the exercise. The first part of the exercise, I want everyone to do these. Okay.
Okay.
All right. So remember, the answers are in the printed material, so don't let them look at the like. I hope they don't look and find the answers. Okay. All right. So you guys go ahead and take a break, and I'll see you guys at in about 15 minutes. And I'll let you, so Easter and Abiodun, I'll let you guys run this exercise. I'm going to keep this up on the screen so you can show them, hey, go ahead and fill this out. You can work in teams or as individuals. And then when everyone's filled it out, let me know. And then I'll start going through each one of these one at a time. Okay.
Okay.
All right. We'll see you guys in 15 minutes.
All right. Thank you. Yes, actually, I was looking for you to see. Well, that's the one they asked you to. Who did you say you wanted to? You said,